If you subscribe to the channel, you'll get lots of interesting videos like this one. And if you like the video, it'll really help us out. Please comment down below for any other interesting things. That also really helps us out as well. Hi, welcome to another edition of Easy Theory. So before we were talking about these things called direct proofs, which is that we wanted to prove something, some kind of assertion directly, some proposition directly. But now what I want to do is to look at a different proof technique, which is proof by cases. So it actually is a direct proof technique, but the difference here is that we're going to separate the proof into several different cases and handle each one of those cases directly. Instead of handling the whole proposition or assertion all at once, we're going to look at it in each of the cases and handle them separately that way. Therefore, we don't have to use a general argument to work with all of them. So here's an assertion that I want to prove, which is, so here's my claim, that for all j and k being integers, and actually there's no crossbar there, if j is even and, oh no, not and, sorry. If j is even or k is even, then j times k is even. Okay, so this is just saying that if we have, if we're multiplying two numbers and one of them is even, then the product of them is even, and we can intuitively see that that's the case. But we actually have two different cases here, where j is even and the other one where k is even. You could make the argument that since j and k are arbitrary integers, that these two cases are symmetric, and then in the second case we could just replace k with j, but we might as well just carry through this. So let's look at case 1, which is j is even. So if j is even, that means it's some integer times 2. So if j is even, that means j is equal to 2 times some integer. I'm going to call it m, where m is an integer. So what does that tell us then? Well, once we make this assumption, let's look at what we need to prove, that j times k is even. So j times k, well, alright, so j times k is equal to 2 times m, just by doing the substitution right here, times k, well, that's just some integer. And what we notice is that we can wrap parentheses around the m times k because multiplication is associative. So I can move the parentheses however I like, although it doesn't really matter here. We know that this guy right here is an integer because it's the product of two integers. And so 2 times some integer is even. And so therefore this whole thing is even. And that's not hard to see. And as we can see, as we're going to do right here, case 2, if the case of where k is even, then that means that k is equal to 2 times, I'm going to call it n this time, so that there's no confusion here. So k is even. I don't know anything about what j is. So then j times k is going to be j times 2n, because I'm just substituting 2n here. Well, so note that multiplication, you can do the multiplication in any order that you want. It's something called commutative, where you can do the multiplication in any order that you want, for integers at least. So I can move the 2 out on front, and then j times n on the inside, and do the same trick that we did before. And we know that j times n is an integer, because they're both integers. And so this thing is even too. Okay, so what we did here is that we split the proof up into multiple cases. And the pro tip here is if you see something like if something or something, um, which is saying that there are two different cases, that is an indicator that you should do proof by cases here. So hopefully that was interesting. Leave any other thoughts about proof by cases down into the comments. There are many links down in the video description if you want to support the channel, such as our Patreon or our Discord server or many social media stuff. And as always, I'll see you next time.